Alright folks, we're going to do number 47 and number 48 at the same time. So I'm going to upload two of the videos, same videos, because they're really the same thing. So I'm going to start with number 47. Alright, let's get started. Two vectors A have a precisely equal magnitudes. For the magnitude of A and B to be 100 times larger than the magnitude of A minus B, what must the angle be between them? Now, I'm going to conceptualize this more than anything else, folks. You have vector A, and you have vector B. And both of these have precisely the same magnitude. Maybe not the direction, but... So the magnitude of A is going to be the same as the magnitude of B. Let's just say that they're the same. So that means that if this vector is in some direction, I'm going to arbitrarily put this horizontal. Realistically, you could tilt this. And vector B is going to be some direction that's going to point upward towards the side. And notice that vector B can have these little endpoints right here. I know I didn't draw them that well, but notice that vector B can have a bunch of these little endpoints, because that's what it is. So notice that I drew a circle, because if they have equal magnitude, the end result when you add them, A plus B, is going to be whatever that, wherever these points happen to be. So think about that when you do this problem. So I hope this makes sense, folks. If you have vector A and vector B, the end result could be either of these points. So notice that we're not really doing this problem just yet. So I'm going to use the law of cosine, folks, and I'm going to look. I want you guys to look up the dot product very closely. So we're going to be using this. So how are we going to do this? Well, it's asking for vector A plus vector B to be n times the magnitude. The magnitude of this, it has to be n times the magnitude of vector A minus vector B. So vector A plus B could be in this direction. And the angle between him, the way I drew it, is 90 degrees. So let's say vector B is somewhere like this. Maybe it ends at that point. So, and notice that now if you were to kind of rewrite this, this is vector B right here, but I'm choosing it to write it in that component, because you're thinking of vectors as some magnitude in the direction. So this data is going to be the component of the magnitude of vector B, the angle between vector A and B, and the dot product. And the dot product is, you take those components. So let's do that. Let's actually write this result. So I'm going to define vector A, and since we're dealing with two directions, let's write a vector S as AX and AY. And vector B, not that we probably might not need to do this, but it might help, is the vector BX and vector BY. And I'm going to do this a little harder than what the solution manual does. The solution has actually a really different answer, but the result is no doubtly the same. So I'm going to put the solution manual after this problem. You guys can look at that, however they solve it. I don't know how they solve it. I just know whatever method works that I figure out is the method that I'm going to use for these videos. So, all right, so let's think about this. How are we going to get started? And this problem is going to be a little longer than usual. So this is vector A, right? And this is vector B. So that's going to be vector A, and this is going to be vector B. And notice that I'm thinking of this as whatever this angle is. And notice that they're the same magnitude. So I am thinking of this vector as in like A plus B as in some direction like this, and the vector of A minus B as in pointing in the opposite direction. So if you were to take that negative B component and flip the direction, this would be vector A minus B. So vector A plus B is going to be this right here, vector A plus B. Vector A minus B is going to be some arbitrary direction that's going to point in that direction. So let me erase that. So notice that I'm just really conceptualizing this problem more than anything else. All right, So let's compute the magnitude of vector A plus B and see what we get. And let me write the dot product so before I get started. So I'm going to write the dot product as A dotted with B equals the magnitude of A, the magnitude of B, of the cosine of the angle between A and B. And the magnitude of A plus B is going to be AX plus BX, that's the X component, and AY plus BY. And we're going to take the magnitude of that. And A minus B is going to be AX minus BX, AY minus BY, and we're going to take the magnitude of that. So let's take the magnitude of this thing, and I'm going to go very fast, guys. So the magnitude of that is going to be the square root of this whole thing square. And notice that I'm going to go really fast, folks. I'm going to put AX squared plus BX squared, but I'm going to reorder this. AX squared plus AY squared, or wait, how am I going to do this? Plus AY squared plus BX squared plus BY squared. So notice I took this square, I FOIL this, but I'm kind of doing this at the same time, plus this square, plus 2 of that thing, plus 2 of the other thing, but I'm going to factor out the 2, and I'm going to put it as a plus, 2 of AX, BX, plus AY, BY. So notice right there, folks, that is the magnitude of A plus B with the square roots. And I'm going to pull that on the side. I don't have much room here, but that's all right. And I'm going to put N, and I'm going to take the magnitude of A plus B, but I'm going to put it as the square root to get started. So this is going to be the same thing, AX squared plus AY squared, BX squared, plus BY squared, and instead of the plus, it's going to have the minus. So we're going to be taking the 2 of the AX, BX, plus AY, BY. Notice that right off the bat, I'm just computing the magnitude. I'm writing the components down as they go along. But notice, folks, that I'm going to take this whole thing and I'm going to square this. So I'm going to rewrite as this. And notice that I'm taking the square root symbol, folks. If you're perceptive, if you stare at this, notice that the magnitude of A squared is going to be AX squared plus B. Oh my God. And the magnitude of B squared is going to be BX squared plus BY squared. And why am I doing that? Why am I writing it like that? Because if you're perceptive, already you can see the variables that we're going to be replacing here. We're going to be rewriting this whole thing. And notice the dot product, folks. Notice that the dot product of A dotted with B is going to be AX, BX plus AY, BY. So notice right off the bat that I am going to be replacing this whole thing as the magnitude of A squared plus the magnitude of B squared plus 2 of the dot product of A dotted with B equals the magnitude of A square plus the magnitude of B square minus 2 of the dot product of A dotted with B. So, and this whole thing has to be in parentheses. There we go. So notice that, folks, all I'm doing is rewriting this. So let's simplify this. So let's simplify this left part. So let's simplify this as this. And what I'm going to do, and we're almost done, folks, is what we want to find, what the question is asking is the angle between them. And notice that you can see problem 48 in my sheet here. So I'm going to be solving for the dot product of A plus B. Pretty tedious. And like I said, folks, the answer, they solve it differently. I don't know how. I'm sure it's pretty straightforward. It might be easier than this, but this is just the way I chose to do this problem. But it's the same thing, folks. It's you get the same result regardless. Maybe it's just looks different. So I'm going to isolate, because remember, the overall end result is, our goal is to get the angle between A and B. And since we already have the dot product, we can simply replace those. But let's not replace those right away. Let's isolate that first. So I am going to take the n square, or I'm going to take the I'm going to take this piece right here, A plus B. And I am doing the algebra as I'm doing these videos. So I'm going to take this piece, and I'm going to minus this portion of it. So that's going to be n squared minus 1. That's the result. And I'm going to take that 2, and I'm going to put that on the other side. So that would be, so that's going to equal to the 2 factor out with the n squared plus 1 with the dot product. So this is going to be A dotted with B. And I've done this before, so I think I can do the algebra in my head. I don't think I would get that confused. So this would be the n squared plus 1, I believe. Yeah. So so here you have 2 of the A dot B plus 2 of the A dot B with the n squared. That 2 gets factored out. The A dotted with B gets factored out. So you'd be left with 2 of the n squared plus 1 on the whole thing. So boom, there's your equation right there. Now we're not done yet, folks. We're almost there, but we're not quite there. And I really hope you guys are enjoying this video. So now we're going to replace the dot product. So we're going to say A dotted with B. Cosine of the angle between them is going to be the magnitude of A square plus the magnitude of B square. The whole thing of the n squared minus 1 over the 2 over the n squared plus 1. And we're going to take those two magnitudes and we're going to be putting them in the bottom. So we're going to take that and we're going to put this in the bottom here. I'm going to move this on the side. So, and there you go, folks. Actually, I guess I'll put this right here. So that's it, folks. That's all it is. There is your equation right there. Cosine of the angle, cos inverse is going to be whatever this result is. So what must the angle between them? So let's write the variables down. Let's actually answer these. I want you guys to notice one thing though. Notice that A and B are the same. So what I'm going to do is I'm going to re-simplify this. I'm going to go a little further and say that this is going to be A 2 times that of the n squared minus 1. So I'm just going to call the B as these two magnitudes added together if they're the same. And the same thing with this. So this is going to be, and that's going to be square. And this is going to be square with the 2 of the n squared minus 1. Beautiful, folks. This cancels off. So you're left with the beautiful equation of the, and yes, folks, it does work. 2 of the n squared plus 1 and minus 1. There is the equation that I derived for you guys. Beautiful, folks. So there's going to be the cos inverse. So what we're going to do is we're going to let n be 100. And I got the answer as theta being 1.1459 degrees approximately. So I'm kind of running to the 4 decimal places. So that's the answer. Notice that theta is very small. So it has to be A, so the magnitude of A plus B would have to be pointing almost in the same direction. For this to, when you take the magnitude of A minus B, where you would be adding the opposite side to be 100 times larger than the other one. So that is the solution, folks. This is for 47. I really hope you guys enjoy.